If you're wondering why I'm over here typing away, then that's why. So yeah, you guys should definitely check that out after this talk if you're still around. And yeah, this is the bytes track. So the whole idea with this is like spider bytes and stuff like that. So it's more of an attack sort of track versus the bits over there, which is a little more technical and into kind of non-attack sort of stuff. But anyway, this is Aaron, and I hope you enjoy his presentation.
Thanks, everybody. Thanks for coming out. Welcome. I've got kind of the dueling banjo laptop thing going on here because I can't get display on here. So if my slides don't match what I'm saying, I'm doing them in sync. And so yell at me if that's the case. Test. Can everybody hear me? All right, so we'll just go right into it. Wicrawl, what are we here to talk about today? We're going to talk about a new wireless scanning auditing tool called Wicrawl. And here's the agenda here, who I am, current state of wireless, what Wicrawl is, what it does, how it works, some use cases, examples, screenshots, demo, the whole kind of thing. Also, I have some live CDs of the tool, if I forget to mention it, with backtrack as well. Who am I? Aaron Peterson. I'm the project manager and a developer for Wicrawl, founder of Midnight Research Labs, which is a kind of security-based research group based out of the Bay Area. Started about a year ago. There's lots of social groups, social, technical security groups in the Bay Area, but not, very many that are, actually doing things, projects and things like that. So I wanted to start a group. Also the co-founder, consultant with Alpha Defense, co-founded it with Bill here in the audience. Consultant by day, pen tester at night. Here's a little blurb on MRL, what we do, monthly meetings, projects, etc. And so if you're in the Bay Area, look us up, midnightresearch.com. Here's the current state of wireless. The picture might be a little dramatic, but wireless is everywhere. Access points. Everybody, probably the first thing they did when they got to their hotel was, pull up Kismet, pull up NetStumbler, see how many access points are out there, see what you can connect to, try to get internet, those types of things. And the problem is there's so much wireless that it's really difficult to pull out what we really care about. And that really applies to a lot of different use cases. And we'll talk about all those different use cases and how Wicrawl fits those things in a second. But here it says here, we don't want to have to manually scan through these access points. We don't want to have to try to associate to each one, get an IP, look at really what is in this access point other than it exists. Again, having Kismet come up and tell you that there's, 50 access points. We got 42 in our hotel last night with no antenna, internal card. And, we scanned through them and only a couple were, that time we just wanted internet access. So, only a couple were useful, especially when you get to large numbers. If you have a big antenna, so some of the pre-background for Wicrawl is I live downtown San Francisco, and I could get access to about 300 plus access points with a very small grid antenna, and I didn't want to have to crawl through all those things. So I wrote a quick Perl script to, just iterate through, try to associate, see what was there, and I'm lazy. I just want to hit a button, have it go. So moving forward, what? For wireless, there's a few different. These are the general use cases that are sort of outlined for Wicrawl. We've got the pen testing group, security professionals who really want to, drill down into a given access point, a given, device, see what it really is, see if it's vulnerable, see if it's, connected to your network, those kinds of things. Your IT person are often concerned with access points on their network that aren't supposed to be there, rogue access points. In the last 6 months or a year, everybody's been talking about internal threats, those kinds of things. Well, a rogue access point is, it's a $50 thing. You stick it into your network that completely subverts your security for your, your entire network. So if somebody installs that, you want to know about it. Getting and staying on the internet, again, that's sort of just like the business traveler. I travel a couple times a month, and I don't want to have to, find access. I just want to have it through. Again, last night there was 42 access points and only a couple of them were useful. Or, you know, the group of people who just wants to search through, you know, look for curiosities, those kinds of things. What's behind that access point? The magical land of Narnia, or the soft, chewy underbelly of my corporate network being exposed. So we want to look through those different types of things. So Wicrawl comes in. And what that gives us the ability to do is to have more goal-oriented checks to filter through these different access points based on plugins and profiles, which I'll go on to. And so what that allows us to do is filter down to just the pieces of information that we care about, whether it's, you know, things that we can get onto the internet through, or whether it's a piece of equipment that's on my corporate network, things like that. So what's Wicrawl? It's a little kind of markety blurb there. You know, auditor, flexible, simple, passive discovery, and active crawling. That's actually the most important part of that, is that we can discover all the access points, but we can actively crawl through them to find out what's there. Powers in the plugins. The plugins implement discrete checks for individual things. The examples here, you know, can we associate? Can we DHCP? Can we map the network? You know, checking for proxies, those types of things. One of the cool features I think about Wicrawl is it allows multiple cards and actually run plugins over multiple cards at the same time, so that you can have one card just doing discovery and all the rest of the cards, you know, in parallel plowing through these access points to try and find, you know, the information that we care about. You know, that's different things to different people. We've got a pretty cool GUI. We'll show it. Some extra things like GPS support, text-to-speech, hooks for doing external things, doing an antenna. There's where you can get it. midnightresearch.com/project/Wicrawl. I'll put that up after this speech. There's a few different parts to it: the discovery, the plugin engine, the plugins themselves, profiles, which determines how we run it, and the UI itself. And we'll talk about each one of those. Kind of a generic architecture diagram. Basically just puts all the pieces that I was just talking about into little boxes and puts them here. Not too useful, but the point is we've got a cloud of access points and cards for each one of those things. So let's talk about the discovery engine. Discovery engine by itself is what we have more or less today. Today what we have is Kismet and NetStumbler, and that tells us that an access points exist. It just, you know, looks for these things and finds that. So that's its job. Does passive discovery, obviously requires monitor mode, handles different radio header types, which is actually kind of important for all the different drivers. We can dump the traffic and send that to the plugins so that the plugins have access to look at the information that we've been capturing, and then talks to the plugin engine through IPC. It was written by Jason Spence, the man in the red hat right here. So here's the architecture overview here. We've, you know, it starts from libpepcap. We pull it apart, and it goes to the hyperpimp, patented trademark name there, and then flows up through IPC into the plugin engine. Plugin engine itself, basically it takes all the information that we get from the discovery engine and schedules all the other pieces that we need. For example, the cards that we want to connect, the plugins that they want to run, and the access points that we want to talk to. And the profile, which we'll talk about, determines all those types of things. It'll turn on and off the discovery engine as needed. We'll talk about how through the plugin engine. SSID filtering, which is important, so we don't scan access points that we are not supposed to be. So plugins themselves. The plugins are, I would say, the most important part of Wicrawl, because that's where the functionality itself is. And a plugin can be anything that you want it to be. It's a pretty simple interface. It's really easy to write these things. We've got about, I don't know, 15 or 20 plugins right now. The plugin engine calls these by passing parameters and things to the environment. And the plugin itself can be any type of executable, you know, a binary written C, or we've got a lot of Perl and Bash ones, or for the fashionable programmers there, Ruby and Python, things like that. we've got a couple templates in the directory that you can take a look at. And if you're interested in writing one, I suggest it's really simple. You can just add a few lines to this template for calling, nmap, for example, or nessus, or things like that, and have it automatically run when you want it to in the correct order for these given access points. Another important thing, I think, is that for these plugins, a lot of really cool tools for wireless that do individual things. For example, AirCrack, I think, works pretty well. AirCrack NG now. However, some of these tools, not AirCrack, is a little difficult to make and build, and maybe a little bit more difficult to use. Meaning, with AirCrack, if you want to, if you use it well, you have to sort of start several things by yourself, sort of manually. And I think it's kind of annoying because I find myself doing the exact same things over and over again, which is a good case for automation. For example, you have to start dumping, and then you want to start doing error replay to try and inject, known ARP packets, and then we want to try and crack it. There's all these threads that run that you manually have to set up. Well, our AirCrack plugin does all those things for you. You just schedule that plugin, and it starts the dumping, the injection, and starts cracking that through the plugin interface. Some more things. I'll try not to get too boring with this, but the workflow for Wicrawl is when it's running the plugins, it has these event levels that it tries to escalate through. Again, we have various levels of access to an access point. The very first level is we know that it exists. The second level is we can actually associate it to it. Now, there's many different things that you have to do to try to associate to it, or it can be many things. For example, maybe all you do is associate directly to it. It's really easy and fast. Or you might need to actually crack WEP or WPA or these types of things to be able to get to on there. Once that happens, you move to the next event level. In this case, we're associated, and then what we want to try to do is get an IP address. Now, that might just mean running DHCP in a large number of cases. Well, it also might mean trying to grab an IP address that's already on that network, or a number of other things, another number of other ways to get an IP address. So you run through these plugins, in order of, what you think is most likely to get you an IP address until you escalate to the next event level. There's 4 basic ones for the scheduled plugins, and we'll talk about what that means. And then there's also some for the hooks, and we'll talk about hooks in a minute, but we can schedule things pre and post discovery and pre and post action. Each plugin can have multiple event levels, such that, for example, there's a text-to-speech plugin that announces things, so that you can associate the text-to-speech plugin to have internet and have IP. So if you're, say, a business traveler and you just want to hit a button and lay down until Wicrawl says, Wicrawl found internet access through access point WeFoo, or something like that, you can just hit the button, let it go until it announces. Anyway, the point is that there's hooks there to trigger these external things. Another good use case is GPS. You want it to trigger right when it happens rather than to be scheduled. Or if you're moving an antenna, you want to record the antenna position right away. Run lengths. They are different plugins will take shorter or longer to run depending on what they are. For example, in the new access point,